A very good evening, class 12th. This is a post after a long time. I had slightly tight schedules, so kindly excuse me for that. Come on, let's begin. I'm talking about Unit 2, 12, sorry, Unit 12, class 12th. The topic is aldehydes, ketones, and carboxylic acid is the name of the chapter. I would be stressing only on carboxylic acid and in this particular video. Fine. We'll be doing the IUPAC nomenclature to begin with, followed by the preparations, physical properties, chemical properties in this particular video. Okay, let's begin. Carboxylic acid looks like this. What it means is the carbon of the carboxylic acid has a double bond O, a single bond O, and an OH. As you can see, this carbon already has 3 bonds. It can only make one more bond, which means this particular group will always be at the end of the chain. Therefore, we call it as a terminal functional group. End में लगेगा. Also, this is the highest priority functional group. मतलब इसको हमेशा नंबरिंग 1 से स्टार्ट करना है. फाइन. फॉर एग्जाम्पल, अगर ये एक कार्बोक्सिलिक एसिड है, काउंट द नंबर्स ऑफ कार्बन इन द आर और इस कार्बन को साथ में काउंट करना. लेट अस से इस कार्बन के पास 5 हैं, तो इस कार्बन को मिला के देयर बी 6 कार्बन्स. यू विल नेम इट एज वॉट एवर इज द नेम ऑफ दैट पर्टिकुलर alkane. Remove the E, add oic acid. So the general name of carboxylic acid is alkanoic acid. I'll take example number 1. Let us say it is this. Now this particular one is a tricky example. I'll take this later. I'll take a simpler example for you to understand it better. Alright. Now in this particular example, let us start the numbering. As I said, numbering would be from here. It has got 4 carbons, so the name is butanoic acid. But there is an OH group at the second carbon. OH is called as alcohol when it is the only functional group. Now in this particular compound, you have 2 functional groups. Out of these 2, इसकी priority ज़्यादा है. So alcoholic group in the presence of carboxylic acid group is called as hydroxy. So the name would be 2-hydroxy butanoic acid. The first alphabet has to be capital, rest all are small. I'll take another example. 1, 2, 3, 4, 5, 6, 7. That's the compound. Now in this case, you should know how to count the carbons. This is your first carbon, this is your carboxylic acid. 1, 2, 3, 4, 5, 6 and 7. So it is heptane. In fact, it is heptene. Heptene is at the 3rd position. So the name of the compound would be hept3ene. You remove the E terminal and add oic acid. Moving to this particular example now. Now this is a cyclopentane and this particular carbon is not inside the chain. So you cannot name it along with the cyclopentane. So this compound is given a special name where we call it as a cyclopentane and this is called as carboxylic acid. Because this carbon is not included in the chain, so it is named separately. I'll just take one more example. Alright, this is a benzene ring. You have a carboxylic, NO2, NO2, NO2. Out of these 3, the priority group is carboxylic. So this will be your first position where the COH is attached. Second, third, fourth, fifth and sixth. You have got 3 nitro groups at 2, 4 and 6. So you have 2, 4, 6 trinitro. Otherwise this compound is benzoic acid. So we name it as 2,4,6 trinitro benzoic acid. Fine. Moving on to the methods of preparation for carboxylic acid. There are large 8-9 methods, so we'll go one by one on each of them. The first method of preparation is from alcohols. Let me take a specific example. Now, if I want to convert this alcohol into a carboxylic acid of 2 carbons, so I am looking for this. Can you see when I move from this to this, तो क्या फ़र्क है? Oxygen has been added. एक ऑक्सीजन आ गया. हाइड्रोजन चेक करिए. 1 2 3 4 5 6 यहाँ पे थे, यहाँ पे 4 है. And you have removed 2 hydrogens. So it is clearly a reaction where you are wanting to do oxidation, which means you will be using oxidizing agents. Now, which oxidizing agents can be used? There are many options. You can use KMnO4 alkaline. You can use K2Cr2O7 acidic, and you can use a reagent called as Jonas reagent, which is nothing but chromium trioxide in an acidic medium. So अगर एरो के ऊपर इन तीनों में से कुछ भी लिखा है, your alcohol, primary of course, 1 degree alcohol will quickly transform into carboxylic acid. कोई भी example इसका ले लो, कोई भी example where you have an alcohol, it will quickly transform into a carboxylic acid. The same is true for aldehyde also. Let me take a simple example of an aldehyde. This is my aldehyde, and I want to transform it into carboxylic acid. 1 2 3 4 5 carbons का है. 1 2 3 4 5 carbons. यहाँ से देखो ध्यान से. What is the difference in the two? As you can see, everything is same. Carbon 5 है, hydrogens भी same है. There is just addition of oxygen. So again, this is an oxidation reaction. You will be requiring oxidizing agents. Which are the oxidizing agents? You can use any of these oxidizing agents and you will get your carboxylic acid. Fine. Moving on to the next. You can prepare carboxylic acid from an alkyl benzene. Let me take an alkyl benzene to be toluene. So this is the toluene. Now if you oxidize it with KMnO4 in the basic medium, KOH or OH minus, this quickly transforms into a potassium salt of carboxylic acid, and after that you need to acidify it to give you the carboxylic acid. So this is the general method by which we prepare carboxylic acid. But in case you have an alkyl benzene of a type जहाँ पर बेंजीन के साथ बहुत सारा लंबा कार्बन चेन लगा हुआ है, इफ़ यू यूज़ KMnO4, वैसे ही ऑक्सीडाइजिंग एजेंट हम यूज़ करते हैं और उसके बाद हाइड्रोलिसिस कर देते हैं, तो व्हाट हैपन्स इज जितने भी चेन्स लगे हैं ना फालतू वालतू के, ये सब हट जाएंगे. सिर्फ एक कार्बन यहाँ पे रह जाएगा. ऑल दिस will transform into CO2 and H2O, which we are not interested. Our interest would be benzene के साथ जो ये first carbon है, this will transform to a carboxylic acid. Rest all the chains will vanish into CO2 and H2O and you will end up in carboxylic acid. कितना ही लंबा chain हो, your major product is going to be benzoic acid. Fine. Moving on to the next method of preparation. The next method of preparation is from nitriles. अब ये nitriles क्या होते हैं? Nitriles are RCN. RCN. That's the structure. इसमें to transform it into carboxylic acid, you need to add dilute HCl. Dilute HCl का मतलब है दुनिया भर का पानी. When you have a large excess of water, the compound gives you carboxyl. This actually breaks down here. Water goes on adding, breaks down here, and water goes on adding. You end up in RCOOH plus you have got NH3 as the gas which is liberated, and you end up in your carboxylic acid by complete hydrolysis. Any alkyl cyanide can be used and you will get your product. Let me take an example. If you have, let us say, methyl chloride, you first convert it into methyl cyanide by using KCN. Then you can convert into a acetic acid by using dilute HCl. So there is a addition of a cyanide followed by transforming it into carboxylic acid. अगला मेथड है अमाइड से. अब ये अमाइड क्या होता है? अमाइड इज RCONH2. फाइन. तो इफ योर स्टार्टिंग मटीरियल इज CH3CONH2 and you want to prepare a carboxylic acid from it, you will be using concentrated HCl or dilute HCl. H पॉजिटिव चाहिए. एडिशन तो बेटा वाटर का होना है. दिस कंपाउंड विल लीड टू अ क्लीवेज हेयर. यहाँ पे OH आ जाएगा, यहाँ पे H आ जाएगा. तो आपका प्रोडक्ट क्या बना? CH3, CO के पास OH आ गया, वाटर, एंड यू गेट अमोनिया. डाइल्यूट एसिड यूज़ करो या कॉन्सेंट्रेटेड एसिड यूज़ करो. आई वुड एडवाइज preferably use a dilute acid so there is large excess of water and so that this water can easily add on to give you your carboxylic acid as the major product. Fine. So it is nothing but hydrolysis again. तो nitriles हों या amides हों, both of them undergo hydrolysis. That's addition of water and you end up into your product. That is carboxylic acid. This is a very crucial and an important reaction which you should know. What is Grignard reagent? RMGX. इसमें स्पेशल क्या होता है? RMGX की ये स्पेशलिटी है कि मैग्नीशियम हैज़ अ पॉजिटिव चार्ज एंड योर R हैज़ अ नेगेटिव चार्ज. नाउ हाउ इज कार्बोक्सिलिक एसिड प्रिपेयर्ड? इसमें क्या करते हैं? आपका RMGX रिएक्ट्स विथ कार्बन डाइऑक्साइड. ये रहा कार्बन डाइऑक्साइड. फाइन. कार्बन डाइऑक्साइड में दिस इज योर नेगेटिव पार्ट, दिस इज योर पॉजिटिव पार्ट. ये इलेक्ट्रॉन ऑक्सीजन अपनी तरफ खींच लेता है. R ग्रुप गोज एंड अटैक्स द कार्बन. तो बेटा यहाँ पर कुछ नहीं हुआ, यहाँ पर O ने नेगेटिव लिया, यहाँ पर यू एंड अप इन दिस R अटैकिंग. यहाँ पे ऑक्सीजन पे नेगेटिव आ रहा है तो ये दिस होल ग्रुप गोज एंड अटैचेस हियर. सो दिस इज द इंटरमीडिएट अडक्ट विच इज फॉर्म्ड फॉलोड बाय हाइड्रोलिसिस. हाइड्रोलिसिस करने से यू एंड अप इन HNOH, दैट इज योर कार्बोक्सिलिक एसिड बन जाता है एंड द बाई प्रोडक्ट इज MgOHX. इज दैट क्लियर? विच मीन्स जब भी आपको कार्बन ऐड करना हो तो यू ऐड कार्बन डाइऑक्साइड इनटू योर ग्रिग्नार्ड रिएजेंट. एक स्पेशल एग्जाम्पल करके देखते हैं इसका. दैट इज फॉर एग्जाम्पल यू हैव CH3MgBr and you add CO2 and followed by hydrolysis. दो स्टेप इकट्ठे कर देंगे तो you would end up in CH3COOH. एक कार्बन बढ़ के मिलेगा and of course MgOH Br तो मिलेगा ही. बाई प्रोडक्ट्स में we are not interested. This is what you are interested in and it is a step up reaction because there is an addition of a carbon atom by the CO2 which you have added. Coming to the next method of preparation is from acyl halide. अब ये acyl halide क्या होते हैं? acyl halide या acyl chloride. Acyl halide and acyl chloride is you have a COX. So I will take an example of a CH3COCl. Now CH3COCl को अगर हमको कार्बोक्सिलिक एसिड बनाना है you require hydrolysis. पानी डालने से आपका काम हो जाता है. कैसे? ये टूटेगा, यहाँ पे OH, यहाँ पे H तो हो गया ना. बट वाटर एडिशन इज नॉट ईजी. वॉट वी नीड टू डू इज एसिडिक हाइड्रोलिसिस. वाटर अकेला नहीं रिएक्ट करता है, इट रिएक्ट्स ओनली इन द प्रेजेंस ऑफ एसिड. सो वी राइट H3O पॉजिटिव एंड दिस रिएक्शन देन लीड्स टू CH3COOH एंड द बाई प्रोडक्ट इज HCl. कोई सा भी एसिड क्लोराइड को अगर कार्बोक्सिलिक एसिड बनाना है, add water in the presence of acid and your work is done. The next is from acid anhydride. Acid anhydride होता क्या है? I am taking a specific example. CH3COCOCH3. Now this is acetic anhydride. इस acetic anhydride में से अगर मुझे carboxylic acid चाहिए तो I need to do nothing but add water. That is by hydrolysis. कैसे होगा? यहाँ पे बॉन्ड टूटा, इधर H आ गया, इधर OH आ गया. ध्यान से देखो, you end up in CH3COOH, CH3COOH, meaning that's 2 molecules of CH3COOH. कोई सा भी acid anhydride हो, on hydrolysis you will end up in the 2 molecules of carboxylic acid. I'll do another example. Benzene, COOH. This is benzoic anhydride. आप इसमें पानी डाल दो. On adding water into benzoic anhydride, you will again see this goes in H here and an OH here. This will lead to molecules of the type where you would have benzoic acid, 2 molecules. Fine. Moving on to the last method of preparation is from ester. अभी ester क्या होता है? Esters is RCOOR. R सेम भी हो सकते हैं. कोई भी एस्टर हो, अगर आप उसमें वाटर या एसिडिक हाइड्रोलिसिस, वाटर डालने से बनता है अगेन, बट वाटर डज नॉट रिएक्ट इजीली, सो या तो आप इसमें एसिड डाल दो, और द अदर ऑप्शन इज यू कैन इवन ऐड अ बेस. इट्स अ रिवर्सिबल रिएक्शन, मतलब स्लो एंड कैन गो बैकवर्ड ऑल्सो. एसिड डालने से क्या होता है? एस्टर ब्रेक्स डाउन, H यहाँ पे, OH यहाँ पे, तो व्हाट डू यू गेट? RCOOH प्लस इस वाले R का अल्कोहल. एक आपको एसिड मिलता है, द सेकेंड मॉलिक्यूल इज एन अल्कोहल. बट व्हाट हैपन्स इफ यू ऐड NaOH? इफ यू ऐड NaOH, दिस ब्रेक्स अगैन, you get an Na here and an OH here. You do not get a carboxylic acid, you will get a sodium salt of carboxylic acid and the alcohol, और इसको then you need to transform it back into acid. तो थोड़ा सा इसमें acidification करने से you will end up into your carboxylic acid. तो ester can transform into carboxylic acid by acidic hydrolysis. That is addition of water in the presence of acid, or by basic hydrolysis. Both the methods are correct for an ester to transform into carboxylic acid. Let me take a specific example under this category. This is the ester. If you add hydrolysis to it, then this will break, you will get an H and an OH. Your products are acetic acid plus methanol. But if you add a base to it, then your products would transform into sodium salt of the acid, because this would again break, give you Na here and an OH here, plus your byproduct remains the same, that is methanol. Fine. With this we end the methods of preparation for carboxylic acid. Moving on to the physical properties now. Alright, talking about the physical properties, we talk about the physical states. Now generally your carboxylic acids are liquids, because carboxylic acids bind to each other. How do they bind? RCOOH is one carboxylic acid, RCOOH is another carboxylic acid, and they prefer to form hydrogen bonding with each other, leading to two molecules to join together. That is, they exist as a dimer, because of which they are generally liquids. From this is up to carbon is equal to 9, they remain liquids, and they are colorless also. But after that, higher ones, if the carbon is greater than 9, then in that case it becomes a waxy solid, and finally it would become again further solid like. Fine. Now other than that, since they have extensive intermolecular hydrogen bonding, as you can see, extensive intermolecular hydrogen bonding means molecules are tightly packed with one another. That is why the boiling points are highest as compared to aldehyde, as compared to ketone, as compared to alcohol, Beyond this, carboxylic acid has higher boiling point because of intermolecular extensive hydrogen bonding. The molecules are associated. You can see they are associated with each other. Fine? Understood? So, even if you boil it, if you have a carboxylic acid, which is a liquid, you heat it, your carboxylic acid churns into a gas, it still remains a dimer because of the strong hydrogen bond which exists between them. It cannot easily break. So even in vapor phase, it remains a dimer. Clear? The third property is water solubility. Now carboxylic acids have a tendency to form hydrogen bond with water. As you can see, this is the intermolecular hydrogen bonding with water. So they are soluble in water up to carbon is equal to 4. Which means if I talk about benzoic acid, then this is got carbon beyond 4. यानी इसमें it is insoluble in cold water. हीट करोगे तो थोड़ी solubility बढ़ जाएगी, पर cold water में तो it is insoluble because the carbon number is 6. कार्बन बढ़ने से hydrophobic. This particular compound has larger hydrophobic benzene ring, which is water insoluble. So अगर कार्बन 4 तक है, they remain soluble in water. That is again due to intermolecular hydrogen bond. That's intermolecular hydrogen bond between water and carboxylic acid. You need to specify where is the hydrogen bond being formed for them to show solubility. This is the illustration that you should give if you are asked for why are carboxylic acid soluble in water. Fine. So the physical properties that we have done are physical state, boiling point are high, water solubility is high up to carbon number 4. Moving on to the chemical properties of carboxylic acid. Any carboxylic acid that you have, the first property is reaction with sodium. The second property is reaction with sodium hydroxide. And the third property is reaction with sodium bicarbonate. So when this happens, since the carboxylic acid are acidic, they replace the H in all the three and your sodium takes its position in all the three. So what are you going to end up with? RCONA, a sodium salt. What is left? An H. That means hydrogen gas will be evolved. Second में क्या होगा? Again RCONA, Na will replace the H because it is acidic. It will easily give off the H. What are you left with? Byproduct is water. The third is an important reaction. This H goes and sodium takes its place. So you end up in sodium salt of carboxylic acid. लेकिन byproduct क्या है? H2CO3. बेटा H2CO3 कभी भी byproduct नहीं होता है. It quickly decomposes into water and CO2. And it is this CO2 which is your brisk effervescence which you can easily observe. इनो जैसे बुलबुले आते हैं इसमें. So I advise अगर कभी carboxylic acid का you are asked chemical test दो. This you can do it in the lab also. आपके practical में भी ये है. Carboxylic acid में add sodium bicarbonate का solution. You will end up in a sodium salt of acetic acid plus H2O plus CO2 is what you will observe. You can watch the video already for the chemical test of carboxylic acid. Just type my name Seema Makhijani and write down chemical test of carboxylic acid and you will reach here. Now this property is referring to the acidic character of carboxylic acid. Carboxylic acid is acidic. अगर पूछा जाए what is the chemical proof, you can give any of these reactions which show that the hydrogen is being replaced by sodium. So these are the reactions which illustrate acidic character. Now as far as the reasoning is concerned, there is another video on acidic character on my channel. Just type my name, write acidic character of carboxylic acid. Is approximately of 18-minute video which you can watch, because I'm not explaining the acidic character in detail again in this particular lecture. We'll continue with the other chemical properties. So if you want to see the chemical test, go ahead. If you want to do the reasoning question on acidic character, please watch these two videos also. Moving on to the next chemical property. This is with concentrated sulfuric acid or phosphorus pentoxide. Now these both are dehydrating agents. ये क्या होता है? They remove water. Fine. Now if they remove water, then how do we go about it? When we talk about them, you have a carboxylic acid. You have another molecule of carboxylic acid. If you add P2O5, these two molecules lose a water molecule and you end up in CH3, CO, O, CO, CH3, which is called as acetic anhydride. If you remember, हमने कार्बोक्सिलिक एसिड बनाया था एसिटिक एनहाइड्राइड से. तो अगर एसिटिक एनहाइड्राइड से आपको कार्बोक्सिलिक एसिड बनाना है तो ऐड वाटर, और अगर एसिटिक एनहाइड्राइड से कार्बोक्सिलिक एसिड बनाना है तो जस्ट ऐड वाटर. एसिड में से एनहाइड्राइड बनाना है तो यू नीड टू रिमूव वाटर, सो यू नीड टू यूज एनी ऑफ द टू डिहाइड्रेटिंग एजेंट्स. Moving on to the next property. This property is called as esterification. What do you require? Esterification में you require a carboxylic acid and you require an alcohol. I'm taking a specific example of alcohol like methanol. On top of it, you require concentrated sulfuric acid. Again, the function of concentrated sulfuric acid is to remove water. Now, this reaction is a reversible reaction. This concentrated sulfuric acid क्या करेगा? Water remove करने में help करेगा. तो अगर इसमें से वाटर निकल जाएगा तो वाटर यू लेफ्ट विद R, CO, O, CH3, and this is your ester. The byproduct is going to be water. एक और एग्जाम्पल कर लेते हैं. CH3COOH plus C2H5OH. Concentrated sulfuric acid will help you in removing water. ये रहा H, ये रहा OH. What do you end up in? CH3, CO, O, C2H5 and ester. Now इस पार्ट का एक स्पेसिफिक क्वेश्चन आता है. इस रिएक्शन में either you should remove water or you should remove ester as soon as it is formed, because the reaction is reversible. अगर आप इसको रिमूव नहीं करोगे, this will go backwards. Can go backwards. So you need to remove either the ester or water. On removing this, according to Le Chatelier's principle, we've done this principle in equilibrium. In that case, if you remove the ester या water को remove कर दें, then according to Le Chatelier's principle, you move towards the forward reaction. Fine. So that's the reason why you should remove the ester or water during this process. The next is reaction of your carboxylic acid with PCl3, PCl5 and SOCl3. ये तीनों reagents का काम क्या होता है? They remove the OH and add the Cl. ये है इनका function. तो क्या करना है? सब में से OH remove करते जाओ और Cl डालते जाओ. So if you add a PCl5, तब भी your product is CH3COCl. If you add PCl3, then also your product is COCl. If you add SOCl2, then also your product is CH3COCl. But byproducts अलग होंगे. इसमें your byproduct in this case CH3COCl आ गया. Byproduct in this case will be 1Cl HCl plus POCl3. इसमें your byproduct is यहाँ पे 3 molecules of acetic acid react with this. 3 Cl लग गए and you end up in a byproduct of H3PO3. ये भी 3 molecules मिलते हैं. इस वाले में when you come to this particular reaction, SO2 and CO2 are SO2 and HCl are the two major products which are gaseous, and that is why this reaction is generally preferred, and this is called as thionyl chloride. Fine. So acids can transform into acid chlorides by using any of these 3 reagents. Next we come to an important reaction called as reaction with ammonia. कोई सा भी कार्बोक्सिलिक एसिड हो और ये रहा तुम्हारा अमोनिया. अमोनिया में बेटा लोन पेयर है, एंड दिस H पॉजिटिव गोज एंड अटैक्स द लोन पेयर. तो नतीजा क्या होगा? RCOO NH4 पॉजिटिव और ये नेगेटिव. यू एंड अप इन अ अमोनियम सॉल्ट ऑफ द कार्बोक्सिलिक एसिड. उसके बाद हम इसको हीट करते हैं. हीट करने से दिस रिमूव्स वाटर फ्रॉम हियर. अगर वाटर रिमूव हो जाएगा तो यू एंड अप इन RCONH2. चेक करो इसमें और इसमें क्या फ़र्क है. कैन यू सी? 2 हाइड्रोजन्स रिमूव कर दिए और एक ऑक्सीजन. सो यू एंड अप इन अ अमाइड. सो दिस रिएक्शन इज यूज्ड अ लॉट in your conversions. So if you have an acid like this CH3COOH and you have to transform it into CH3CONH2 amide banana, so what you will do is add ammonia and then you can heat it and you will end up into your acetic acid will change into a amide. उसके आगे फिर Hoffman bromide कोई भी reaction पूछा जा सकता है. All right. The next is a reduction reaction. कार्बोक्सिलिक एसिड का अगर हम रिडक्शन करें, now what is reduction? Addition of hydrogen. It ends up into RCH2OH. 1 डिग्री अल्कोहल बनता है इससे. हाइड्रोजन ऐड हो गए इसमें, ऑक्सीजन रिमूव हो गया. दैट इज कॉल्ड एज रिडक्शन. नाउ विच मीन्स यू विल बी रिक्वायरिंग रिड्यूसिंग एजेंट्स. नाउ विच रिड्यूसिंग एजेंट कैन बी यूज्ड? लिथियम एल्यूमिनियम हाइड्राइड is one reducing agent. Diborane is another reducing agent which you can use. There is a third reducing agent NaBH4 जो कि हम aldehyde और ketones में use करते हैं. It cannot be used for carboxylic acid to change to 1 degree alcohol. So please do not use it. Of course, along with this you also need some acid for the reaction to take place. So that you need to write that down. But please do not use sodium borohydride. I'll do an example. अगर स्टार्टिंग मटेरियल कार्बोक्सिलिक एसिड है, एरो पर लिथियम एल्यूमिनियम हाइड्राइड लिखा है, तो आपका प्रोडक्ट बन जाता है CH3CH2OH. क्लियर? कमिंग टू द नेक्स्ट, डीकार्बोक्सिलेशन. इसका क्या मतलब है? -CO2. इसका मतलब है आपको CO2 हटा देना है. अब इसमें क्या होता है? दिस इज़ योर कार्बोक्सिलिक एसिड. इसमें हम पहले NaOH डालते हैं, तो यू एंड अप इन अ सोडियम सॉल्ट ऑफ कार्बोक्सिलिक एसिड. इसके अंदर फर्दर NaOH प्लस CaO. दिस मिक्सचर इज कॉल्ड एज सोडा लाइम. दिस हेल्प्स इन रिमूवल ऑफ CO2 एंड Na2CO3. दिस लीड्स टू द फॉर्मेशन ऑफ R. के पास सिर्फ H आ जाता है ये वाला, और बचता क्या है? Na2CO3. ये रहे 2 Na2 C, 1 2 और 1 ये 3 O3 H जाके. This just catalyzes the reaction. This is not used up in the reaction. I'll give you 2 examples. This is important for conversions. You should know how to go about it. Carboxylic acid, benzoic acid अगर हो, एरो के ऊपर NaOH प्लस CaO और हीट लिखा हो, तो you should understand कि ये बेंजीन बनेगा. एक और एग्जाम्पल, CH3CONA, एरो के ऊपर अगर सोडा लाइम है, ऑफ कोर्स हीट भी होगा बेटा, यू हैव टू हीट इट. बिना हीट के तो होगा नहीं. दिस विल लीड द CO2 टू मूव आउट एंड यू विल एंड अप इन मीथेन मॉलिक्यूल. फाइन. Next is halogenation, and this is for addition of chlorine and addition of bromine only, और कुछ नहीं. इस रिएक्शन की इंपॉर्टेंस इसलिए है कि इसका नाम है हेल वुलहार्ड जेलेंस्की, दैट इज HVZ के नाम से भी इसको शॉर्टकट में हम बोलते हैं। कोई भी कार्बोक्सिलिक एसिड हो, कितनी भी लंबी चेन का, ये रहा, इन दिस कार्बोक्सिलिक एसिड अगर यू ऐड द हैलोजन एंड रेड फॉस्फोरस, मैंने Cl2 डाला है, एंड ऑल्सो यू ऐड वाटर, तो क्या होता है बेटा, जो अल्फा कार्बन होता है ना, सिर्फ उसका H हटता है, यानी योर प्रोडक्ट वुड बी, R को कुछ नहीं होगा, CH2 को कुछ नहीं होगा, इस CH पर एक H हट के Cl आ जाएगा, एंड योर COH को भी कुछ नहीं होगा, तो बाय प्रोडक्ट क्या होगा, HCl, एक Cl यहाँ आ गया, H निकला और वो HCl के साथ लग गया, फाइन। द सेम रिएक्शन इज ऑल्सो एप्लीकेबल, लेटर से मैंने ये लिया CH3 CH2 COH, एरो के ऊपर लिखा हुआ है Br2 रेड फॉस्फोरस एंड वाटर, तो अल्फा हाइड्रोजन ये है, CH3 को कुछ नहीं होगा, अल्फा हाइड्रोजन में से H निकल के Br आ जाएगा एंड COOH। इस रिएक्शन की इंपॉर्टेंस है क्योंकि इसका नाम है, इट इज़ अ नेम्ड रिएक्शन कॉल्ड एज, इट इज़ एक्चुअली अल्फा हैलोजनेशन। कार्बोक्सिलिक एसिड ग्रुप को कुछ नहीं होता है, अल्फा हाइड्रोजन गेट्स रिप्लेस्ड बाय either chlorine and bromine, और कुछ नहीं, only for chlorine and bromine. Moving on to the last property of carboxylic acid, which is your ring substitution. Ring substitution का मतलब I am talking about benzoic acid. अगर हमको benzoic acid का नाइट्रेशन करना है, मतलब नाइट्रो ग्रुप डालना है, तो हमको ये बात पता होना चाहिए कि द नाइट्रो ग्रुप कहाँ आएगा, जहाँ पे कार्बोक्सिलिक एसिड बोलेगा। कार्बोक्सिलिक एसिड हैज़ गॉट अ minus R effect. Also, it is an electron withdrawing group. Therefore, it is meta directing. So, your NO2 would come to the meta position. अगर हम इसकी ब्रोमिनेशन करते हैं तब भी ये, अगर कार्बोक्सिलिक एसिड यहाँ लिखा है तो द ब्रोमीन वुड कम टू द मेटा पोजिशन अगेन। नाउ डालेंगे क्या, द रिएजेंट दैट यू रिक्वायर फॉर ब्रोमिनेशन इज Br2 एंड द लुईस acid FeBr3. Nitration के लिए what do we use? Concentrated nitric acid plus concentrated sulfuric acid is what you do for ring substitution. Now, there are two more reactions. If you use CH3Cl in the presence of anhydrous AlCl3, there is no reaction. Friedel-Crafts alkylation is not possible in it. And if you try to do CH3COCl and anhydrous AlCl3, then also there is no reaction. मतलब Friedel-Crafts reactions, whether it is alkylation or it is acylation, both the reactions do not take place. It is maybe because of the deactivating influence, and this Lewis acid reacts with this particular acid, hence the reaction does not take place. So the Friedel-Crafts reactions are not a part of this. This is one important fact which I want you to know about carboxylic acid. Tollens and Fellings test, आपको लग रहा होगा ये तो weird बात है, this is valid for aldehydes, but there is one carboxylic acid. ये कौन सा carboxylic acid है, methanoic acid. What else can we call it? Common name is formic acid. Red ants में से मिलता है। Methanoic acid या formic acid में बेटा aldehyde group है. That is why they give both Tollens as well as Fellings test. मतलब अगर आपके पास HCOH है and you are adding AgNO3, that is ammonical silver nitrate, to it, then it ends up in HCOONA plus your silver gets deposited and you have ammonia evolved. So silver mirror test, and if you add Felling solution, that is A plus B, you end up again in the carboxylate ion plus you end up in copper 2 oxide, which is orange PPT, and this is your positive Fellings and tolerance test. The only carboxylic acid जो tolerance और Fellings test देता है is methanoic acid. But if you are generally talking about carboxylic acid, तो all carboxylic acids will give you sodium bicarbonate test. Carboxylic acid में add NaHCO3 का aqueous solution and you will end up in RCOO. Na, you're not interested in this. You'll get water. You're not interested in this. You will get brisk effervescence, and that is what you're interested in. Fine. With this, I have ended carboxylic acid for CBSE by Seema Makhijani. Hope you're liking the chemistry classes that I'm doing. This is a part of your unit 13. Some part of it, of course. Majorly what we have done is your unit 12 carboxylic acid section, where we did nomenclature, preparation, physical properties, chemical testing. Fine. That's it. All the best. Do well in life. Bye.